Hello everybody. Today I'm going to talk about the use of photoresistor in your IoT projects. You can see the setup here. I'm using the NodeMCU with the Wi-Fi chip on it, but I'm not really using the Wi-Fi capabilities. I'm just using the processor to process the signal basically, and you can use the output of this signal that the NodeMCU is reading to your advantage to control the other devices that you want to. I'll talk more about controlling other devices in the subsequent videos. But basically, let's go through the setup here. What I have done here is basically this is the power. This is the power, 5-volt power coming from the NodeMCU. The first in the series is the LED, just to show you the color intensity changes because the current going through the circuit changes, so the intensity of this LED glowing will change as we brighten or obstruct the light falling on the photoresistor. This is a 300 ohm resistor, the next in series, and then the next in series again is a 10 kilo ohm 10 kilo ohm resistor again in series, and then we have a photoresistor here, and then the yellow line is the ground, and this sort of reddish line is the signal where I'm picking it up. So basically what you'll observe here is, as I am obstructing the light falling on the photoresistor, you'll see the light intensity changing. So basically what's happening here is the resistance of the photoresistor is changing, which changes the current in the circuit, and since the current and the resistance are changing, the voltage delta across this photoresistor, depending on the circuit, the voltage that I'm reading is different, and hence the reading will be different. So let's look it up on the serial monitor here, what the numbers are. So I'm spitting out some numbers here, and you can see, and I will slowly put my finger on the photoresistor to obstruct the light, and you will see a change in those numbers. So the number is increasing here, and if I remove my finger, the number goes back. Again, the number is increasing as I'm obstructing the light, and again. So the basic fundamental is the resistance is changing, which changes the current and hence the signal. Now I'll show you, if I change where I want to read it, pick up the signal, it will change the number. So if you see the range here, it's around 425 to maybe max we have seen is what, 800. So now I'm gonna change this pin where I'm picking up the signal. Oops, LED came out. Okay, so I will put it right where the two resistors are meeting, and now I will play. Right, so the current through the circuit is not changing because we didn't change any electrical parameters, but the voltage is changing now, and hence you will see here, see it started, you see some ones before, it's mainly because I disconnected it totally, and now the ranges are different. It goes from 900, and then if I put the finger on top of it, it goes to 925. Now I've removed the finger, 891. So you see the range is different, and the span of the range is also different depending on where you pick up the signal. So now I will move it one more step right after the LED, or just right after the LED. let's see what the numbers will be. Okay, so now it's right after the LED. I don't know if you guys are seeing it properly. And now the number appears to be hardly not much different, because the only delta P that it's sensing is the LED, the delta P across the delta voltage across the LED. Okay, so now I changed the circuit yet again. I switched on the power connection from the board. So the power connection is now coming here. Earlier the power connection was where the yellow line is, so I swapped the red and the yellow line. So now the current is flowing from this guy, from the red pin to the yellow pin through the photoresistor as the first electrical resistance, then the 10k resistance, then the 300 ohm, and then the LED. So again, since the electrical components are not changing, the current through the LED is not changing. As I'm obstructing the light, the current should still be the same, because it's just the direction is changing. But now again, depending on where I'm picking up the signal, the number that will be displayed on the screen will be different, because now I am reading the delta voltage across the photoresistor. Now I'm putting my finger on top of it. 545, 931, 500, 900. So as you saw, the numbers are again different. The range has widened. The numbers are different. So you can use this change in the signal or output to control the whatever you want to control. Again and again, the applications may include like controlling light, for example, when it's evening time or when it's dark time. You can use this input to trigger on the lights, turn on the light when the value reaches certain number. So you'll have to calibrate that number to your needs based on your circuit that you have designed, and use that value to control the other electrical gadgets that you want to control. It could be a light, it could be, hey, turn on the infrared camera just because it's a night time, or whatever you want to do. In the subsequent videos, I'll probably upload few videos to show its use to either trigger on a light using a relay with or without the use of internet, or you can, yeah. So stay tuned. Thanks for watching. Bye.